Hello everyone, welcome to our channel. So in this video I am going to discuss about how to draw loading diagram from the given shear force diagram and how to draw loading diagram from the given bending moment diagram. Okay, so first case is अगर हमको shear force diagram दिया हुआ है क्वेश्चन में, तो by using that shear force diagram हमको loading diagram कैसे निकालते हैं. ओके, दिस इज फर्स्ट केस. एंड इन सेकेंड केस अगर हम क्वेश्चन में बेंडिंग मूवमेंट डायग्राम दिया हुआ है, देन फ्रॉम यूजिंग दैट बेंडिंग मूवमेंट डायग्राम हम लोडिंग डायग्राम कैसे बनाते हैं, इसको हम सॉल्व करेंगे. सो द फर्स्ट केस इज हियर. द फर्स्ट केस इज दिस इज द फर्स्ट केस. इस क्वेश्चन में हमको क्या दिया हुआ है, शेयर फोर्स डायग्राम इज गिवन ऑफ ए पर्टिकुलर बीम विथ सम लोडिंग. उसका शेयर फोर्स डायग्राम दिया हुआ है, हमको लोडिंग डायग्राम निकालना है. ओके, सो फ्रॉम द गिवन शेयर फोर्स डायग्राम हम लोडिंग डायग्राम कैसे निकालते हैं. सो बिफोर सॉल्विंग दिस क्वेश्चन वी हैव टू नो फ्यू इंपॉर्टेंट थिंग्स. दैट इज, फॉर सपोज the slope of the shear force diagram, at any particular point will give you load intensity at that point. That is, slope of shear force diagram at any particular point in the beam will gives you load intensity acting at that point. Load intensity at particular point, for suppose at some point A मान लो, वहाँ पर अगर shear force diagram का slope निकालते हैं, that will give you the load intensity that is acting in the beam at that particular point A. Okay, you can indicate like this: dV by dx at some particular point A is equals to load intensity that is acting at that point A. Okay, and the second important point is, due to the presence of point load in the sense, for suppose there is some point load is acting like this. Okay, point load, or you can say sudden load. So due to the presence of point load in the shear force diagram, there may be sudden rise or sudden fall. For suppose this point load is acting at point A. At this location, as this load is in downward direction, this is the sign convention for shear force diagram. This is the sign convention on the left side of the section. Due to upward force, sudden rise of shear force will take place. So due to from at this section, if you consider, due to the downward force, there will be sudden drop in the shear force diagram. So the point you need to understand here is, due to the presence of point load, there is a sudden rise or sudden drop in the shear force will takes place. Okay, so second point is, due to the presence of point load, there is sudden rise or sudden drop will takes place in shear force diagram. I am only comparing between shear force diagram and loading diagram. हम अभी बेंडिंग मोमेंट डायग्राम के बारे में नहीं बात कर रहे हैं. ओके, क्यों? शेयर फोर्स डायग्राम से हम लोडिंग डायग्राम निकाल रहे हैं, इसलिए शेयर फोर्स की डायग्राम के बीच में और लोडिंग डायग्राम के बीच में रिलेशनशिप निकाल रहे हैं. ओके, सो अगर द थर्ड पॉइंट, अगर लोड इंटेंसिटी इज n degree curve in the sense, for suppose there is some triangular load is acting on the beam. There is some triangular loading like this is acting on the beam. For suppose this is a loading diagram that is acting, that is a triangular load is acting on the beam. This triangular load is nothing but 1 degree curve. Why? This is a linearly varying loading, linearly vary over a load. This will be like y is equals to mx plus c, this kind of curve. That is a straight line, not straight line, a linear curve. So this will indicates 1 degree curve. So for this curve, the shear force diagram will be n plus 1 degree curve. That is nothing but 2 degree parabola you will get it. For this load intensity, you will get 2 degree parabola. If you consider bending moment, that will be n plus 2 degree curve. That is 3 degree curve. Okay, so the point here you need to understand is, for suppose the load intensity is n degree curve, then the shear force diagram curve will be n plus 1 degree curve, and the bending moment diagram will be n plus 3 degree curve. Okay. For suppose if there is UDL, UDL is nothing but like W constant, that is 0 degree curve. UDL is 0 degree curve. So the shear force diagram for this load intensity will be n plus 1 degree curve, that is nothing but 1 degree curve, that is like linear curve, and the bending moment diagram will be n plus 2 degree curve, which is nothing but 2 degree parabola. Okay. So the point you need to understand here is, for suppose the load intensity is n degree curve, for suppose the load intensity is n degree curve, then n plus 1 degree curve will be shear force diagram, and n plus 2 degree will be bending moment diagram. Okay. So these 3 points you need to understand before solving this question. Okay. Before solving this question, you need to understand these 3 points. Okay. So अब क्वेश्चन को सॉल्व करेंगे. Here, if you draw a shear force diagram, I will draw here. Okay. So first of all, this is the shear force diagram he has given. At point A, there is a sudden drop in shear force. Shear force diagram में sudden drop हो रहा है. That is 5 WA by 4 is the sudden drop that is taking place at point A in case of shear force diagram. So what we have discussed in previous three points, अगर shear force diagram में sudden drop or sudden rise होना मतलब there is some point load is acting. Okay. At point A, in negative direction in the sense shear force is negative at point A. ड्यू टू दिस पॉइंट लोड शेयर फोर्स में क्या हो रहा है, नेगेटिव वैल्यू, नेगेटिव शेयर फोर्स आ रहा है. उसका मतलब दिस इज द साइन कन्वेंशन फॉर शेयर फोर्स वैल्यू. ऑन द लेफ्ट साइड ऑफ द सेक्शन ड्यू टू अपवर्ड फोर्स shear force will be positive. So at this section if you consider, and the left side of the section there is shear force is negative, shear force negative हो रहा है. इसका मतलब the point load will be acting in downward direction. Here the point load will be acting downward direction, which will be equals to 5 WA by 4. This is the loading diagram. This is the shear force diagram, and we are making loading diagram here. We are making loading diagram. And after that, from A to B, क्या हो रहा है, shear force में कुछ variation नहीं हो रहा है. It will be like a straight line. So straight line मतलब shear force diagram is a 0 degree curve. Okay. So from point A to B, there is no change in shear force. There is no change in shear force. The slope of the shear force diagram क्या है इसमें? Slope of the shear force diagram from A to B, here I will write, from A to B, slope of shear force diagram क्या है? 0, which is nothing but slope of shear force diagram, that is dV by dx is equals to load intensity at that point. So up to from point A to B, slope of the shear force diagram is 0, because it is a straight line. Slope of the shear force diagram is 0, which means from A to B there is no load is acting. From A to B there is no load is acting in the loading diagram. After that, from B to C, what is happening? From B to C, the shear force diagram is varying linearly. So shear force diagram is varying linearly in the sense this is a 1 degree curve. Okay. So this is a 1 degree curve in the sense the loading will be 0 degree curve. 0 degree curve in the sense 0 degree curve in the sense some UDL is acting. Some UDL is acting. So here what is happening, this slope will indicate what? This slope will indicate the load intensity acting at that point. The load intensity acting at that point. From B to C, the shear force value is gradually decreasing in a sense. In negative direction it is increasing. So this slope of shear force diagram from B to C will give you load intensity acting at that point. From B to C, shear force value is increasing, but slope of the shear force diagram is constant, which is nothing but some UDL is acting from B to C. Okay, on which direction it is increasing? If you consider from point B to C, the shear force value increasing but in negative direction. But in negative direction, it is in a sense, if you consider at this section as compared to B to here, the shear force value is increasing in the negative direction. So the load intensity will be in this direction. Okay, so from B to C, slope of the shear force diagram, what is this slope? What is this value? This value is given in the in this one is 9WA by 4, and this is 9WA by 4. We have to calculate the slope of this value. The slope of this diagram we have to derive. That is 9WA by 4 minus 5WA by 4 divided by A, which you will get for W. That is W you are getting. So the load intensity is nothing but W. In which direction it is acting? Negative in downward direction. Downward direction in the sense it will give you negative shear force. Okay. So after that, what is happening? There is a sudden rise in shear force diagram at point C. At point C, there is sudden rise in the shear force diagram. Sudden rise in the sense there is some upward force acting at this point. At this point, there is some sudden upward force is acting at this point, which will be equals to the sudden rise. Jitna sudden rise हुआ, that will be equals to the point load that is acting here. Here from 9WA by 4 minus 9WA by 4 से 2WA तक rise किया था. इसका मतलब this point load will be equals to 9WA by 4 plus 2WA, which will be equals to 8 plus 17WA by 8. So 17WA by 4. So this point load will be equals to 17WA by 4. Okay. So after that, what is happening? There is no change in shear force. Shear force diagram में कुछ change नहीं हो रहा है. मतलब it's a straight line. So there is no force is acting at this point up to C to D. C to D से तक C to D तक कुछ changes नहीं है shear force diagram में. It's a straight line. So that indicates there is no load intensity is there. At point D, what is happening? There is some sudden drop at D, which means there is some downward force is acting at this point, which will be equals to the change in the shear force value, that is 2WA. So this will be the loading diagram. By using only few conditions, we are drawing all these things. So finally you are getting like this. The load intensity diagram is here. You are getting 5WA by 4. After that, after a span of A, you are applying some UDL up to distance of A, which is nothing but W, and after that some point load is acting at this point, which is 17WA by 4, and up to a distance, after a distance of A, at the end there is some point load is acting, which is equals to 2WA. Okay, so this is the loading diagram we have derived from the given shear force diagram. Okay, so अब मान लो अगर गिवन shear force diagram में कोई couple present हो, मतलब if there is some couple movement is acting in the shear force diagram, in the loading diagram, for suppose if there is some couple is acting in the loading diagram, if there is some couple is acting in the loading diagram, then we cannot, there is no change, there will be no change in the shear force diagram. क्यों? shear force diagram में couple के द्वारा कोई अंतर नहीं पड़ेगा, there will be no difference. मतलब due to the presence of point load, there will be a sudden rise or drop in the shear force diagram. Due to the presence of UDL, there will be some changes. Due to the presence of any loading, there will be some changes in shear force diagram. But if there is some couple is present in the beam, there will be no change. मतलब अब मान लो यहाँ पर कोई couple अप्लाई किया था, अब अभी कुछ 2WA ऐसा कुछ मोमेंट अप्लाई किया था, उसका इसका शेयर फोर्स डायग्राम में कुछ अंतर पड़ेगा क्या? कुछ नहीं पड़ेगा. क्यों? ड्यू टू प्रेजेंस ऑफ कपल, शेयर फोर्स डायग्राम में कोई चेंज हम नोटिस नहीं कर सकते. सो फ्रॉम दैट वी कैन से दैट द derived ओके, हमने जो लोडिंग डायग्राम बनाया था, it will satisfy the force equilibrium condition. It will satisfy the force equilibrium condition, but it cannot, it may or may not. अगर लोडिंग डायग्राम में मोमेंट प्रेजेंट हो, then it cannot satisfy the moment equilibrium equation. ओके, सो टू इक्वेट मतलब हम इस बीम को मोमेंट इक्विलिब्रियम कंडीशन को सेटिस्फाई करना पड़ेगा. ओके, इसलिए हम मोमेंट इक्विलिब्रियम कंडीशन को चेक करेंगे. आफ्टर दैट वी विल अप्लाई सम मोमेंट टू बैलेंस दिस बीम. ओके, so we will apply some moment externally in such a way this beam will satisfy moment equilibrium condition. तो पहले it will satisfy force equilibrium condition. It will definitely satisfy force equilibrium condition, but हम एक बार चेक करेंगे. अब मान लो सिग्मा एफ वी इज इक्वल टू 0 चेक करेंगे. What were the downward forces that are acting? 7 WA 5 WA by 4 plus 2 WA plus W into A. On this side you are getting 17 WA by 4. अब A value equal होना चाहिए, which is nothing but 5 WA plus 312 WA by 4, which is nothing but 17 WA by 4. So both are equal. Upward and downward forces are equal. So this loading diagram is satisfying force equilibrium equation. अब हम moment equilibrium चेक करेंगे. This is point A. मान लो sum of the moments acting at point A with respect to point A चेक करेंगे. अब मान लो सैगिंग मूवमेंट को पॉजिटिव, क्लॉकवाइज मूवमेंट को पॉजिटिव मानेंगे, तो दैट इज डब्ल्यू ए इंटू ए प्लस ए बाई टू ड्यू टू दैट यूडीएल प्लस 2 WA. अब हम इसको पॉजिटिव मानेंगे क्लॉकवाइज मूवमेंट को. 2 WA इंटू 3 इज माइनस 17 WA by 4 into 2A. Okay, so after solve, if you solve, that is 2 plus A 3 W A square by 2 plus 1 3 WA square by 2 plus 2 3s are 6 WA square minus 17 WA square by 2, which you are getting, you will get 2 WA square, that is you get 12 WA square. Here you will lose 14 WA square by 2, which will be equals to WA square minus WA square. So what it indicates, there is some net movement is acting on the beam. Net movement is some net movement is acting. Which one? WA square minus indicates anti-clockwise direction. So we have to apply some clockwise movement. We have to apply some clockwise movement on the beam. At any point, at some point, at any point, we have to apply some clockwise movement to keep the beam in moment equilibrium. To keep the beam in moment equilibrium. So for that, we have to apply WA square movement on the beam at any particular point, but in clockwise direction, because this is the net movement. There is the net movement that is acting on the beam right now. So to keep the beam in moment equilibrium condition, we have to apply same quantity of movement but in opposite direction. Here net movement that is acting is in anti-clockwise direction, so we have to apply clockwise movement. We can apply this clockwise movement at any point. अब मान लो इसको हम पॉइंट ए पर लगा सकते हैं, कुछ भी फ्रॉम ए टू बी कहीं भी अप्लाई कर सकते हैं. ओके, आई एम अप्लाइंग हियर. हाउ मच आई एम अप्लाइंग? WA स्क्वायर. एंड इन व्हाट डायरेक्शन आई एम अप्लाइंग? इन क्लॉकवाइज डायरेक्शन. क्यों? अभी तक WA square in anti-clockwise direction beam में present है. Okay, so finally this will be the loading diagram of this beam. This will be the loading diagram of the beam. Okay, so this you should mention. So हम यहाँ से कुछ ऑब्जेक्टिव पॉइंट्स क्या निकाल सकता है. मैंने आज टेलीग्राम चैनल पे एक क्वेश्चन भेजा, एक क्वेश्चन अपलोड किया, क्विज जैसा क्वेश्चन भेजा था. क्या है? द लोडिंग डायग्राम दैट वी हैव डिराइव्ड from the given shear force diagram will satisfy first one force equilibrium condition, second one moment equilibrium condition, third one is it may or may not satisfy moment equilibrium condition. Okay, so it will definitely satisfy force equilibrium condition for sure, लेकिन moment equilibrium condition को satisfy कर सकता है, नहीं कर सकता है, it depends. Okay, अगर satisfy nahi kiya moment equilibrium ko, we have to apply some moment, we have to keep some moment on the beam such that the beam satisfies moment equilibrium condition. Okay, so the answer for that question is it will definitely satisfy force equilibrium condition, it may or may not satisfy moment equilibrium condition. Okay, this is the answer for that question. I guess you have understood this question. uh, you have understood the logic behind that question by now. Okay, so this is how uh, we derive, or we draw loading diagram from the given shear force diagram. In my next video, I will I will discuss how to draw how to draw loading diagram from the given बेंडिंग मोमेंट डायग्राम. ओके, इन शेयर फोर्स डायग्राम अगर दिया हुआ है तो शेयर फोर्स डायग्राम में क्या करेंगे, शेयर फोर्स डायग्राम से लोडिंग डायग्राम बनाएंगे, फ्रॉम दैट लोडिंग डायग्राम वी विल ड्रा बेंडिंग मोमेंट डायग्राम. ओके, अगर इन सेकंड केस बेंडिंग मोमेंट डायग्राम दिया हुआ है, बेंडिंग मोमेंट, अगर बेंडिंग मोमेंट डायग्राम इज गिवन, फ्रॉम दैट बेंडिंग मोमेंट डायग्राम वी विल ड्रा शेयर फोर्स डायग्राम, and after from that shear force diagram we will draw loading diagram. Okay, from that diagram we will draw loading diagram. These type of questions are very important for IAS conventional point of view also, and from these concepts we can solve few objective point of view questions also. Okay, in next video I will discuss how to draw uh, loading diagram from bending moment diagram. So thank you everyone for watching this video. Please subscribe to my channel if you find this the content I am discussing here is useful for your preparation. Please like and subscribe to my channel. Thank you.